interesting facts and data that Ed and another what do I want to say, very well-educated, experienced gentleman collaborated on to give us this presentation. And his name is Dave Hyde. Unfortunately, he can't be here tonight because he's at his home in Austin, Texas. And I want to tell you a little bit about him too, because I think it's really important to understand the credentials of our speakers here. Dave retired from a 38-year career in undersea technology development. He has a PhD in physics and a double E from the University of Iowa, good Big Ten school. He has worked for SecNav, Department of Defense, DARPA. He was technical director of undersea surveillance systems, and he got into some pretty spooky stuff that we can't even talk about here because he'd have to shoot us if he did. Secretary of the Navy, Distinguished Civilian Service Award, worked for Texas Instrument for 6 years, the Scripps Institution of Oceanography, I think you probably all know about that organization, SAIC, Neighbor and Professional Associate with Walter Monk, SIO, Dean of U.S. Physical Oceanography, and he's been a consultant, Defense Science Board, Navy Research, and I could go on for another 2 or 3 minutes here. But he and Ed collaborated to bring you this next presentation.
Yeah, I hope I will do justice to this. Let me just give a little background. David and I didn't know one another, and we were working along parallel paths. So I was gathering data, and David was gathering data, and we were coming to the same conclusions. And then we met one another and found out we'd been working on the same stuff. As Dave Cable explained, I'm a geologist, and I know about oceanography from the geomorphology and hydrogeology aspect of it, and I've worked on shoreline sites. But David's really an oceanographer. He's very strong in this stuff, and I will try to do justice to his presentation. First of all, I just want to say that this is the Salish Sea, and this is the kind of watershed of the Salish Sea. And there are 3.7 million Canadians who live in it, 3.4 million Americans who live in it. And both David and I were basically reviewing the literature and the science associated with this area to see how it compared to bass and what had been submitted for bass, the best available science. And in particular, what the connections were among these various parts of the Salish Sea, because while it may have one name and people may be wanting to connect it socially and culturally, it's different subsystems when it comes to the way the ocean currents work. And so we reviewed the ocean circulation literature in order to derive assessments and then present them here, which is what we're about to do next. And Dave Cable's gone over all this stuff. You don't need to see it again. It's just who I am and who David Hyde is. The science, first of all, there is a tremendous amount of very good science associated with the oceanography of the Puget Sound, Salish Sea, Straits of Georgia area. And one of the main things that it points to is the fact that there are different circulation systems. So there's the Puget Sound system, which, although politically we may be tied to, oceanographically we are not tied to. There's the Strait of Juan de Fuca. There's the southern Straits of Georgia and the northern Straits of Georgia. And what this side view of the map is showing you is that red area right there, that's the Strait of Juan de Fuca. This area down here is Puget Sound, and that area up there is the Straits of Georgia, the southern Straits of Georgia. And the colors have to do with tidal influence and fluvial influence. And the word fluvial, you're going to hear me talk about that throughout this talk. Fluvial means river. It's what geologists call rivers. And you'll see that many parts of the Salish Sea are really heavily dominated by fluvial systems. Others are more dominated by tidal systems. And it's been a really active area of research. Everybody from the University of Victoria to MIT and Scripps has done research up here. It's been one of the favorite places for doing research. Okay, next one. This is just going into detail about some of the circulation domains used by the ocean models. And the ocean models, there's the Princeton ocean model, there's the regional oceanographic model, there's several different sort of well understood numerical models. And the literature has done a very good job, I think, of comparing actual data to models. If you want to scare the heck out of a groundwater modeler, you ask him if his model has been calibrated, because it's very hard to calibrate. It's very hard to get your model to actually match existing data. But what's really interesting about the oceanography studies is that the models pretty much match the data. Boy, that's hard to do. That's really rare. And that's what we find in this area of the Salem Sea. So this is trying to divide up and explain the different subsystems and how they've been studied. Again, just the southern Straits of Georgia, Puget Sound, so on and so forth. Next. And again, the Princeton Ocean Model and Regional Oceanographic Modeling System. I don't know how much people know about those, but those are very well understood and well used and widely used numerical models for predicting ocean currents and just physical oceanography in general. And there's a tremendous range of data, a tremendous amount of data out there already, which we don't feel has been included in the BAS. We know it hasn't been included in the BAS. And it's really significant information that should be included in the best available science. That point up top is just showing the length of Puget Sound and how some of these models have compared with observed data. And just by looking at the colors, you can see that the models matches the observed data, which is really remarkable. Yeah, next. The circulation systems match. The salinity matches. The Juan de Fuca system transports fresh water. You know, the way the system generally works is the Juan de Fuca system transports fresh water, seawater in and out, and has strong tides, and it interacts with both the Puget Sound system and it interacts with the southern Straits of Georgia system. But the southern Straits of Georgia system, which San Juan's is part of, really, because of the Juan de Fuca, doesn't interact that much with the Puget Sound at all. And so these are really separate systems. And so while the Juan de Fuca system may interact with both Puget Sound and Straits of Georgia, the Straits of Georgia doesn't really interact that much with the Puget Sound model. So San Juan County waters are almost completely contained within the southern Straits of Georgia system and are not physically connected in any statistically significant way with Puget Sound waters or its urban runoff areas. So we may be in the United States, but oceanographically we're Canada. Next. And, you know, because of that, we're affected by Canadians. You know, that's what the science essentially is telling us. This is the watershed of the Fraser area. It's a huge area. And it encompasses most of British Columbia's population. And you throw that in with the areas that actually border the Straits of Georgia, and we're affected predominantly by BC's population and by what BC puts into its water. Many parts of this area are dominated, like I say, by river systems, and some of the later slides will show that. But the Fraser River obviously is the most dominant river within the area, and it has peak summer flows that average about 3,400 cubic feet, 3,500 cubic feet, and it dumps 20 million tons of sediment every year into our waters. And some of that sediment reaches us, and a lot of that sediment is dumped in the foreset of the delta. But people may not know this, but Point Roberts used to be one of the San Juans. Over the last 10,000 years, the Fraser River Delta has built out and captured one of the islands. And Point Roberts is actually one of the San Juan Islands that's been captured by the Delta. Yeah, next. One of the points to emphasize is that Canada is doing a better job when it comes to pollution trends. Much better job. I mean, this is showing what used to come out of Canadian mills, and what used to be in crabs, and what used to be in sediment concentrations. And you can see over time, Canadians have done a very good job. And I know everybody likes to complain about the Victoria sewage thing, but they're getting on top of that as well. But what you'll see in the science is that we live in the best mixed waters of the United States. I mean, the waters here are exchanged quite rapidly and quite often, and that's why Victoria can do what it does and really have no effect on the environment, because we're very well mixed. So this is just showing contaminant trends in Canadian waters over time. Next. And sometimes these contaminant trends don't fall the way you would expect. I mean, transient male orchids have in this slide show that they have the highest levels of contaminants in their tissues, and they spend most of their time offshore. So we're part of Canada, and sometimes these contaminant trends don't match with what you might think. Next. One thing to mention about this area is that in the next few slides that I'm going to be showing, we're going to be showing them along a particular transect. And that transect runs from Juan de Fuca through Harrow Strait and up through the Straits of Georgia. So you'll see it as one line, but it really goes from Juan de Fuca, Harrow Strait to the Straits of Georgia. And there's a couple of bathymetric features that separate these areas into a couple of different zones, 3 different zones. There's the Victoria Sill. Sill basically is a name for kind of an underwater ridge. So there's a Victoria Sill, which is located right about here near Victoria. And there's the boundary waters, or the boundary pass sill, located up there. And you can see it's at either end of Harrow Strait, which kind of separates Harrow Strait a little bit from the rest of these areas and kind of forms a separate system. Next. And that's what this is showing. So if you go from Puget Sound, there's the Victoria Sill. That kind of jagged area in the middle is Harrow Strait, and this is the Straits of Georgia, this kind of deep water over here. And what this is showing again is this point that I've been emphasizing, that the observed data matches the model data. So this is observed data versus model data comparison, top and bottom. When it comes to salinity in a kind of lateral or cross-sectional sense. And this is observed versus model data when it comes to salinity with respect to time of year. So this is day of the year, 0 to 365, and that's salinity. You can see that, you know, in the summertime, when there's in the summertime, salinity is deeper. Salinity is higher in the deeper levels, and you get a freshwater lens up top, so you get kind of strong river flows affecting the freshwater top layers. And that's what happens in oceanographic systems. You have kind of shallow water effects and deep water effects in estuarine and oceanographic areas. And I had an old professor who used to say that it's the exact opposite of people. You know, in terms of the way rivers flow out into the ocean and the way salt water flows into a restricted basin or something, it's the opposite of people. It's in at the bottom and out at the top. And that's the way that goes. And so you'll see in some of these next few pictures, you'll see river water along the top, and you'll see the bottom layer being very different, the return flows being very different. Next. Now, there's been a lot of talk about feeder bluffs and where does the sediment come from our beaches and things like that. And there's several different sediment sources for these areas. I mean, the northern and eastern part of the San Juans are very fluvially dominated. Harrow Strait's a really interesting place because it's very tidally dominated. And again, we have the Victoria Sill, we have Harrow Strait, and we have the Straits of Georgia. And just like a river that's kind of running over rough gravel in a river, you get these strong tidal currents running over the Victoria Sill and running over the Boundary Pass Sill and the kind of rough topography of Harrow Strait, and you get sediment kicked up, and that's what this is showing. These colored areas are showing something which basically equates to sediment in the water and cloudiness in the water. Next. And these are just more examples of observed data showing how the top layers are very different from the bottom layers throughout this particular area. And comparison between model and actual. Next. Again, more model and more actual data. I won't go belaboring this, but it's very good science. It's very good data associated with models. Next. This is a very interesting slide because it's showing the effect of the Fraser River and the output and discharge of the Fraser River. And you can see here the San Juans here. You know, there are many slides, aerial photographs. This is just one, which shows the plume extending all the way down to the San Juans, which are located in this area. So you tend to get tidally dominated currents and things like that on the, that are kind of year-round, relatively even on the west side of the San Juans. And on the east side and on the north side, you get very fluvially river-dominated types of interactions, which contain a lot of sediment. So there's plenty of sediment sources around here. They don't necessarily come from feeder bluffs. Thanks. Again, some more data and models, just kind of showing the fluvial domination of some parts of the Salish Sea. Next. and more. And this is just a literature and operational findings. This is, go ahead, next. Yeah, again, the main points to emphasize, no, go back. Yeah, the main points to emphasize is that the Salish Sea isn't the Salish Sea. The Salish Sea is a set of subsystems oceanographically. The Salish Sea, that part that we live in, is connected to Canada. It's not connected to the United States in any significant way. 99% of what we experience is because of the Canadians, not because of any kind of political association with Puget Sound. You know, and there are many more Canadians than there are of us. I think I calculated this once. I think we represented, because scientists like to put things in parts per million, I think we represented something like 2,000 parts per million of the population associated with the Salish Sea. And the Fraser River watershed and the efforts of the University of Victoria and British Columbia and UW and MIT have resulted in decades worth of research that hasn't been included in the best available science. Next.
It has not been?
Has not been. Has not been. Whatever goes into Canadian waters affects us. Fortunately, Canada's doing a better job, but really, we are not contributing. Whatever problem there might be here, we are not contributing to the problem. We're totally dominated by what happens north of the border. And even despite all that, because we're in one of the best mixed, best flushed areas really in the country, and maybe the world, despite what Canadians might put in the water, we're still a relatively good environment. I think that's what you see sometimes in some of the contradictions that come around. You know, you see, we were turned down by I think it was EPA or Ecology because we wanted to do some studies on the water around here, and they said we were too clean. You get this kind of dichotomy where people are very afraid of pollutants going into the water, but we're also very well flushed and pristine as well. So we're not likely to be affected by things even if they get in the water. And there are, of course, exceptions to every rule, and not every part of the San Juans is entirely well flushed, but that's, again, consistent with Common Sense Alliance's view that if we have a problem, we should fix it, but we shouldn't imagine problems where there aren't any. Next. So, I pretty much covered this already. Local tides create turbulent mixing. We're very well mixed. Best flush coastal waters in the lower 48 states. And local scale issues aside, San Juan County coastal zone runoff to the ocean is very rapidly transported to Juan de Fuca and to the Pacific Ocean. And I believe that might be it. Bottom line assessment. Yeah, again, more of the same. We are, this kind of last point, I guess is the closing line, is that the oceanographic science is very mature and well tested and really involves several different extremely reputable institutions. And it's just a shame that that hasn't been brought into the fold in considering what goes on here. That's where we got some of our information. There's a couple I haven't added, but anyway. David Hyde did an extremely thorough job. He took some initial work that I did, and he went very, very deep. And so I hope when he gets back in January, anybody who has any questions or wants to go into any particular area in more detail, David will be able to do that.
Questions? Janice?
Boy, this is going to be a tough question to ask because I just feel so ignorant. It is really hard for me to understand all the scientific data, and I've studied these slides, and to me the more important thing is less the data. That I understand these models are really good ones, the science is excellent, and I'm going to trust that for right now. But some of the implications that I see in this are huge. And what I would love for you to do for us is to give us the principal implications of these data the Fraser River system, the flushing, what goes on in San Juan County versus the CAO, how much impact it has, and that kind of thing. Is that a clear question?
Yeah, let me see if I can do that, you know.
Okay,
Okay.
thanks.
San Juan County is part of Canada, oceanographically. We are extremely well flushed. The San Juan, oceanographically, the San Juan Islands are not uniform. The eastern part of the San Juan Islands and the northern part is heavily dominated by fluvial systems by the Fraser River, especially in the shallow layers. So the shallow layers of water are dominated by fluvial systems, and the return flows underneath are dominated by tidal systems, ocean return flows. And that affects pollutants. It affects what we put into our waters. It affects how it's flushed. It affects when we find something. It affects the source, state and transport, about whether or not we're responsible for it or whether somebody else is responsible for it, and whether any regulation that we might put in place could have any effect on anything in the first place. I guess the last thing that I want to emphasize is that you know what you think might be happening. You really need to check with real science, with actual science from all these institutions in order to make sure that you are conducting the right hypothesis test and you're doing the right thing. So I'm not sure if that answered your question, but I tried to summarize it as best I could. Yes, ma'am.
What is it that we fear from leaving the CAO the way it is? Is it the DOE that's a threat to us, and how can we, combat that?
Yeah, I don't know. We're required to review and if necessary revise. And I can only repeat what some council members maybe have said, but I can't really put my finger on it either because I agree with you. I don't know what the issue is that we're trying to address. And if you don't know what issue you're trying to address, you can come up with any damn solution. I have heard some people recently say that our previous sensitive areas ordinance was not based on science, and so we needed to base our new CAOs on science. Well, that hasn't happened. That just hasn't happened. No matter how many times we seem to go with this, we just can't seem to incorporate the right science in order to make the right conclusions about things. So I wish I knew as well. Yes, sir.
That's really my question is, I understand this wasn't included in the best available science synthesis. Is there some reason that is the case? I mean, I understood there was a public input opportunity and anything could be submitted for consideration. Is there some reason why this type of information, which seems entirely relevant, is there some reason this hadn't been submitted?
Yeah, I can only say my personal story for why I didn't pull this information together in time. And that's just because I have a real job. It's hard to pull all this information.
Well, I understand, but I mean, a lot of the stuff that you put up here is established science. It's stuff that's been done.
Oh, you're absolutely right.
Previous years.
And I guess the only point that I'm trying
It's
to make
well
is that
known.
on the kind of compressed time schedules and the rush to get this done, sometimes rushing to get something done doesn't necessarily mean you do it right. And anyway, I would hope that now that David and I have pulled this together and this evidence is available, that the county might reconsider Bass and might want to consider this as part of Bass. I would hope that's the case. I think you had your hand up, then Stephanie, then you.
I don't quite understand your point about sediment. Is any sediment on the San Juan beaches, does that come from the Fraser River system? And if so, relative to the bluffs on San Juan Islands, how important is the Fraser River system to the sediments on our beaches?
Sure, let me give you my theory about sediment transport in the San Juans overall with respect to the bluffs. And that is that this whole idea about feeder bluffs came to light when a geologist looked at the various bluffs and identified different stages of what geologists call mass wasting. So areas that are more eroded. He drew a conclusion that a more eroded look means that it's feeding more sediment into the littoral system, the beach system today. That may not be true. I mean, it could be absolutely inaccurate. And when you look, at least the observations that I've done, When you look at the beach sands that are on San Juan Islands, many of the San Juan Islands, petrographically they're different from the stuff in the bluffs. The rocks don't match, the sand doesn't match, the sediment doesn't match. A lot of it is reworked marine sediments that are just underneath the waters, and typically you tend to get erosion during the winter and aggradation during the summer. So a lot of it is just reworked marine sediments that are continually moving about and not necessarily active erosion from the cliff face. And even proponents of these feeder bluff ideas admit that at most, it probably erodes at about 1/3 of an inch of a year. And I've gone back and I've looked at historical photos, and I've gone back and I've looked at maps dating back to 1875 that have been geo-referenced by the Department of Natural Resources. And there is no significant erosion for decades, for 100 years. And so that would tend to indicate that these feeder bluffs really aren't feeding that much into the sediment system. Now, it's true. On the eastern side of the San Juans, where you have the Nooksack River, where you have the Fraser River, you can see, I mean, there's scientific evidence that shows sediment from those rivers reaches the San Juans. And yes, some of those sediments do make up our beaches here, absolutely. On different parts of the San Juans, that may not be the case. It may be more reworked marine sediments like the Harold Strait tidally dominated area. You tend to get reworked sediments kicked up from the bottom and deposited on the beaches. You just rework over and over. Yeah, sorry, I called you Stephanie. You're Carrie, right?
Yeah.
Yeah.
I'm just curious to hear what you and/or the Common Sense Alliance, do you have an opinion on sea level rise in the San Juan Islands?
I don't have an opinion about sea level rise in a quantitative sense. I mean, sea level around here has been changing. I mean, that's just part of geologic truth. It's been as much as 50 meters lower and 90 meters higher in the last 10,000 years. And it's probably going to continue to change. I don't know exactly what the sea level rise might be here in the San Juans, but there probably will be some. I mean, I'm not a global warming denier. I believe it's absolutely happening. That doesn't mean I believe all the science about global warming, or that it isn't used in some ways for personal advantage. But nevertheless, I do agree that sea level is rising, but I don't know what the exact amounts are.
Yeah, I'd just like to make a comment as a member of the Common Sense Alliance that's relevant to this, is that we wanted to know, look, is there a problem? Are homes contributing? So we actually commissioned an engineering group to go out and take samples between the houses and the shoreline. And we did 10 samples. Well, actually, we did a couple even. We did one over by because we wanted to test an industrial area, so we did one over by Lawson's Pond as well. And what we found was that even with homes that had been existing for many years, never mind new homes with new technologies and new septic systems, that there was basically, it was insignificant or none as far as contamination. So how is that relevant? The issue is how much. What is the gain that somebody is hoping for by making these changes relative to the damage to personal property rights? This is the issue. I mean, again, it was said way earlier. If there's a real gain, tell me what it's supposed to be, and let me, maybe I can take a bullet for that. But there hasn't been anything demonstrated, and we certainly would encourage any other organization to commission a study as well, because this was not a manipulated field. We wanted to know, because if there was one, then we thought we can be proactive about how to deal with that. We couldn't find anything. Canadian water coming down here, the effluent from 3.5 million people flowing through here, we are not making any difference in anything, and there is nothing relevant to be gained. Anyway.
Mike, you had a question.
To what extent is the current coming from Olympia that extends up through the islands and washing things out?